ladies and gentlemen, and welcome to our flipped classroom. So today we're going to continue talking about the scientific method. So we already talked about steps 1 and 2. Step 1 is writing a good scientific question that is testable. Step 2 was writing a hypothesis that had an if, then, because statement. So today we're going to talk about steps 3 and steps 4. So the third step in the scientific method is to design an experiment. So we have a question, we have a hypothesis that we want to test. Now we're going to design an experiment. Now, when you do this, you're going to need to have a very detailed procedure. All that means is that you have a step-by-step directions. So if you do it once, your directions that you need to write out, people need to be able to duplicate or do again. Kind of like a recipe. And you would also have a list of materials that you need. So yes, on the last video we talked about erupting a model volcano. Well, in your list of materials you would have, model volcano, vinegar, baking soda, things like that. So the very first thing you have to do is write a detailed procedure. Now, what makes a good experiment? Because you can just experiment and put things together and see what happens and woohoo! But how can you really make sure that your experiment's actually testing the things that you want to test? Control. It has to be controlled. And what I mean by that is you can only change one variable at a time. We talked about this in class the other day. If you change more than one thing at a time, how are you going to know what affected the outcome of your experiment? Now, a variable, you might be asking yourself, what on earth is a variable? A variable are the things you change, control, and are looking for in an experiment. The things you change, control, and are looking for in an experiment. This is what you're testing. This is what you're changing. This is the things that you're in charge of in a experiment. So there are actually 3 types of variables that we're going to need to be aware of in every experiment that we do. The first one are controlled variables. These are things that never change from one trial to the next. So that could be like type of equipment. So if you use 60 ounce beaker in one trial, you need to use it in the next one. If you do it the experiment for 30 minutes in one trial, you need to do it for 30 minutes in the next trial. These things have to be consistent, so that way they don't disprove anything, because people could say, well, this wasn't consistent, so how do you know that your findings are accurate? Your controlled variable is what never changes. Okay. You also have an independent variable. I asked you about this in that questionnaire we did last week. So an independent variable is what you are changing in the experiment. And this is what I mean by that. So let's go back to that question about the model volcano. So I wrote a hypothesis for that. If I put more vinegar into my model volcano, then it will have a bigger eruption because the vinegar will create more bubbles. So this part right here, if I put more vinegar into my model volcano, the amount of vinegar is the independent variable, because it's what you are changing, it's what you're in charge of. One trial you might put 2 tablespoons, the next trial you might put 3, then 4, then 5. Okay, so because you are changing it in the experiment in every single trial, that is what makes it an independent variable. Now the other type is a dependent variable. It's what you are looking for in the experiment, what you're testing. So going back to that exact same hypothesis, this time your dependent variable is right here. It will have a bigger eruption. So the dependent variable is the eruption. You're looking to create a big eruption. So that's what your dependent variable is. So controlled variables are what's the same in every single experiment, what make it consistent. Your independent variable is what you're changing from trial to trial. And your dependent variable is what you are looking for in your experiment. Now the fourth step of the scientific method is to collect data. All right, this needs to be consistent and organized. Typically, you're going to do this in a table, and you want to make sure you do this as it goes along. Don't just make stuff up at the end and be like, yay! No, make sure you do this as you go along. Okay, and it also typically needs to be, I can't say this word right now, guys, quantitative data. Quantitative data. Now, data is just information, and quantitative data is just numbers. Okay, so you're looking for temperature, you're looking for time, you're looking for height and size and things like that. So that's how you need to make sure you collect data so you can go ahead and make conclusions and findings and stuff at the end. All right, ladies and gentlemen, those are the steps 3 and 4 of the scientific method. Please make sure that you have completed your notes, done your summary, and asked a question at the end. Thank you so much, guys.